Ever had an AI tool receive 10 when it expected 10 and needed to decide whether to convert it automatically or reject it as invalid? We'll configure FastMCP's validation system that uses Python type hints to generate JSON schemas, giving you explicit control over input handling. You'll see how setting strict input validation equals true enforces exact type matching at the protocol level, while the default flexible mode automatically converts compatible types, all while maintaining FastMCP's write Python, not protocol boilerplate philosophy. Hash enables strict validation for this server. MCP equals FastMCP, strict server. Strict input validation equals true. At MCP, tool. Def add numbers, A, int B, int. Add two numbers. Return a plus B. Hash with strict input validation equals true, sending. 10B, 20 will fail. Hash with strict input validation equals false, default. It will be coerced to integers. This demonstrates configurable contract validation, where input validation becomes a server-level policy rather than hard-coded behavior. FastMCP automatically generates JSON schemas from Python type hints, then validates incoming requests against these schemas before execution reaches your function. The distinctive aspect is how validation strictness becomes a runtime setting, either enforcing exact type matches or allowing safe coercion, without requiring changes to your tool implementations. The pattern works through framework-level interception, where all tool inputs pass through a validation layer before execution. In strict mode, FastMCP rejects any type mismatches during JSON schema validation, providing immediate feedback with clear error messages. In flexible mode, it performs automatic type conversion, like string 10 to integer 10 when safe to do so. This design maintains clean separation. Your functions focus on business logic, while the framework handles validation consistently across all tools and resources. This approach solves the tension between type safety and real-world compatibility in API design. Use strict validation for internal systems where type precision is critical, and flexible validation for LLM integrations where clients may send string representations of numeric data. The trade-off is explicit. Strict mode prevents silent conversions at the cost of potential rejection of valid but imperfect inputs, while flexible mode accommodates variability at the cost of some type precision. The system embodies FastMCP's philosophy of letting you write Python without protocol boilerplate, while still maintaining robust validation controls. Let's break it down line by line. Hash enables strict validation for this server. MCP equals FastMCP, strict server. Strict input validation equals true. This creates a FastMCP server with strict JSON schema validation derived from Python type hints. The framework auto-generates validation rules from your type annotations, enforcing exact type matches without silent coercion. Strings won't become numbers, null won't become empty strings. Use strict mode for internal systems where type precision matters, and flexible mode for LLM integrations expecting variable input formats. At MCP, tool. Def add numbers, A, int B, int. Add two numbers. The at MCP tool decorator exposes this function as an AI callable tool, where FastMCP automatically generates JSON schema from Python type hints. This enables strict input validation at the protocol level, rejecting type mismatches before they reach your business logic. With strict input validation equals true, the server enforces exact type matching, no implicit string-to-int conversion, while flexible mode, default, handles common LLM input variations. Use strict mode for internal systems requiring type precision, and flexible mode for LLM-facing tools where input variability is expected. Return a plus b. This performs the core arithmetic operation, returning the sum of two validated integers. FastMCP automatically generates JSON schema from the type hints a, int, b, int, enforcing exact type matching when strict input validation equals true. The validation occurs during schema validation, before your function executes, ensuring the contract is satisfied at the framework level, not through manual checks. Hash with strict input validation equals true, sending. 10b, 20 will fail. Hash with strict input validation equals false, default. It will be coerced to integers. FastMCP automatically generates JSON schema from Python type hints, enabling strict input validation without protocol boilerplate. With strict input validation equals true, the server enforces exact type matching during schema validation, rejecting strings like 10 for integer parameters. The default false setting allows automatic type conversion, useful for LLM integrations where input variability is expected, but less ideal for internal systems requiring type precision. This validation applies consistently across all tools and resources in the framework. Strict input validation pattern. FastMCP2's strict input validation parameter enforces explicit type contracts by leveraging Python type hints to generate JSON schema validation rules, embodying the framework's write Python, not protocol boilerplate philosophy. The setting applies globally to all tools and resources on the server, ensuring consistent validation behavior across the entire API surface. Validation occurs during schema processing before your tool functions execute, maintaining clean separation between contract enforcement and business logic.
The schema that appears to constrain actually liberates.